Hello everybody. Here's a problem that came to my attention today, and it is from my math lab. I've taken a screenshot, copied it onto my document here. But we're given some data, and it says about 1 woman in 800 carries a mutation of a particular gene. Okay, so we'll just accept that. 1 in 800 women carry a mutation of a particular gene, and about 75% of those women eventually develop skin cancer. Okay, now the question is that suppose that we randomly select a woman and that two things happen in sequence, meaning one after the other. So we randomly select a woman from this population, and she happens to have that gene mutation. Okay, so that's one thing. And then the next thing that happens is that she develops skin cancer. What are the odds that that happens? You select the woman at random, she happens to have the gene mutation, and then later in sequence, the next event is she develops skin cancer. Okay, now that would fall under how do you calculate the probability of events in sequence? And what I mean is the question will be something like, what's the probability that event A happens and then event B happens? Okay? And the way that you'll do that is by multiplying probabilities, but it will depend on if the events are independent or dependent. Now, independent events don't influence each other in any way. Dependent events do influence each other. Okay, so notice here, if I have dependent events, the probability event A happens and then event B happens is the probability that A happens times, now this is conditional probability, here's how you'd read this, the probability that B happens given that A already happened. Okay, so probability of event A times the probability that event B will happen given that A already happened. So we're dealing with, it turns out, dependent events in this question, okay? Because it says that 75% of the women with the mutation develop skin cancer. Okay, so you know, if you knew that the woman had the gene mutation, that would influence the outcome of getting skin cancer, according to that. Okay, so here I'm going to copy down that same formula I had, and I phrased the question of like this: what's the probability that you select a woman with the gene mutation? Okay, because you got this whole pool, this whole population. You select one, she happens to have the gene mutation, and then she develops skin cancer. Now, for shorthand, I say this is event A, this is event B. It would be the probability of event A happening times the probability of event B happening, given that A already happened. Now, the probability of event A, select a woman with a gene mutation, well, that's 1 out of 800. It says so right here. And then what's the probability that the woman will develop skin cancer given that she has the gene mutation? Well, that's this sentence right here. It says about 75% of women with this mutation develop skin cancer. So that's probability of 0.75. So I got 1 out of 800 times 0.75. And that gives me this very small probability, 0.0009375. And in my math lab, at least when I access this question, it said round to 4 decimal places, so 0.0009. Now, I think the key there, I mean, with so many math questions, is just to recognize, well, what kind of question is this, what kind of formula is applicable, and so on. And I draw your attention that, well, this is, we read it, I want it to jump out at you that, oh, we're trying to figure out what the probability is of two events happening in sequence, one right after the other, okay?